Okay, lesson 2 on chapter 3 and competition number 2. Who is the first person to find the 6 types of fruit? So email me for your prize, which will be sent to you somehow. But you will be getting one, okay? And also email your teacher, please. What are the 6 pieces of fruit in this video? I love cherries. Okay, so what is today all about? Today is on the sum of an arithmetic sequence. Write that title in your book. The sum of an arithmetic sequence. What I mean by sum is adding it all together. Now, I want you to have a little think first of all, okay, for my introduction. Can you think of a quick way to find the sum of the first 100 natural numbers? What I mean by that is, what's a quick way of working out and the sum of the first 100 natural numbers? We write it like this. So you can see it's an arithmetic progression going all the way to 100 with the common difference 1 and first term A. Right, now this was given to a child of about 6 years old, long time ago, and they came up with the answer within seconds, and this is what they did. Okay, what they did is they wrote the sequence backwards underneath. Now, some of you might now see what a quick way is. So what this child did is they noticed that each of these 2 terms always added up to the same amount. In this case, 101. And how many lots of 101 have we got here? Well, we've got 100 terms. So we've got 101 100 times. And that would be equal to 2 lots of the sum of 100 because we're adding it up. So 1 lot of the sum of 100 will be this divided by 2. And if you work that out, you get 5,050. So rather than doing 1 plus 2 plus 3 plus 1 in your calculator, this is a much quicker way. Now, why have I shown you that? Well, you need to know the rule, and you need to show this, because I've seen this question come up in exam papers before, to prove the formula for the sum of the first n terms of an arithmetic progression. So what I'm going to do is exactly what I just did for the sum of 100 terms. So the sum of n terms is my first term plus my second term plus my third term plus all the way to my nth term. And I'm just going to extend my paper here, which I can do, plus my nth term. Now my nth term is the last term in my sequence, which will be that. Yeah, because this is the rule for my nth term. So that's the last term in my sequence. Now, if I write this rule backwards, so this was my last term, that's my second to last, all the way to my first term. Now, if you notice, this adding up together is the same as this adding up together, which would be the same as each one if I was to write them all out. So, if I add these up together now, I've got 2a plus n minus 1d. But how many lots of these sums have I got? well, I've got n terms, so I've got n lots. For example, like we did this, how many lots of 101 did I have? I had 100 of them because I had 100 terms. So I write down 2 lots of Sn, because I'm adding up these, will equal here. So the rule for the sum to n terms is this. Just move the end to the front. I've got to divide by 2. Now, you need to know and you need to remember this. Okay, you've got to know this and you've got to know this proof. So can you write that down in your books, please? Oh, after all of that, I could do with an orange, guys. Okay, next. Example 1. The sum of these, find the sum of each of these series. So I'm just going to write down the rule first, which you have to know. Okay, so by using this and writing it down each time, there's more chance of you remembering it. So that's the rule. So my first term in this sequence is 2. My common difference is going up in 4s. And I've got 15 terms, so n is 15. So all I'm going to do is plug all of that into this formula here. So I'm going to plug in 15 divided by 2, 2 times a plus n minus 1 times d. Okay, and I'm just going to work that out. So I'm just going to do that on my calculator. 14 times 4 equals plus 4 equals times by 15 equals divided by 2, and I get 450. Okay, have a go at this one yourself. Example 2, just going down in this case. So pause the video and have a go at this one. So let's just write down the formula first. Always good. I always want to see you writing down the formula in your exams. Okay, so n, I'm doing 30, so n is 30. So I'm finding the sum to the first 30 terms is 2 times a plus n minus 1. Now d is negative 2. Yeah, it's going down in 2s. So here a was 40, d is negative 2, and I'm looking at the first 30 terms. It's good to write that down before you plug them into your sequence. All you're going to do now is just use your calculator to get that answer. So I'm going to do negative 2 times 29 equals plus 80 equals times by 15, and you should get 330. Okay. Right, I think we'll just do one last one. Okay. Question C. Now, I want to find the sum of this series. Now, I haven't been given how many terms I've got in this sequence. So the first thing I've got to do is work out how many terms I've got. So we did this from the previous, in chapter 3a. So I know A, my first term. I know my common difference is going up in 3s. I don't know n. But I know my last term, and this is the rule for my last term, is 91. So let's plug in 4 plus 2, plus 3 times n minus 1 equals 91. So D is 3, A is 4. I'm just going to work this out now. 4 plus 3n minus 3 is 91. 3n equals 92. So n is 92 divided by 3, which doesn't give me a whole number. because that should be 90 because I'm taking away. So it should be 30. So I've got 30 terms in my sequence. Yeah? By making this equal to my last term. So now I'm just going to plug all of this into my formula for here. So n over 2, just write down the formula again. So n is 30 divided by 2, 2 times my first term, plus n minus 1 times my common difference, and then you just get an answer, whatever that is. Okay, so well done. I'm now going to go on to another part of the work. Right, example 3. Cool, I'm really hungry, guys. I need to go and make myself an avocado salad. Starving, just give me a moment. Okay, find the least number of terms for the sum of this sequence to exceed 1,000. Now, have a go, see if you can do that yourself. And let's see how you got on. Find the least number of terms for the sum of this to exceed 1,000. So you've got your first term, your common difference, and we want to find n. Let's plug this in to your formula for the sum of n terms. So we don't know n, that's what we want to find. 2 times 4 is 8, plus n minus 1 times 5. Now, if I make it equal to 1,000, let's see what we got n to come out of here. Okay. So I'm going to just simplify here. I've got 5n minus 5 multiplying out the brackets equals times by 2, so that's 2,000. So I've got n, 3 plus 5n equals 2,000. So I'm going to make my quadratic now. Okay, multiplying out by n, multiply that bracket out, and let's move everything to one side and make it equal to 0. So now you have got a sequence, a quadratic formula, which you need to solve using the quadratic formula on your calculator. Now, n is not going to become a whole number in this stage. So how to do this on your calculator, just grabbing my calculator and just checking this is, yeah, it's still running. You go to menu and you find this button here, equation, and then I'm going to press equals. I want a polynomial, I want degree 2, so my first term a is 5, 3 is equal to b, and c is equal to negative 2,000. I press equals each time, and then my first value here would be 19.7, and my second answer would be negative 20.3. So if you're not sure how to use the calculator, go through that again and check you can do that. It's really important you know how to solve a quadratic formula using a calculator. Okay, now n can't be negative because it's the number of terms. So if n is 19, my sum is going to be less than 1,000. So if n is 20, that's going to be bigger than 1,000. So the smallest, so go back to the question, find the least number of terms for the sum to be bigger than 1,000. So my answer will be 20. Will give me a sum bigger than 1,000. Okay, now there's quite a lot to get through here. I'm going to just do one more example. Okay, I'm going to leave, I was going to do the challenge, but I think the video is getting quite long now. So the question I'm going to do is this one here. This is question 8 from exercise 3B. Have a go yourself first and then pause the video and let's see. So let's see how you got on with this question. Question 8, exercise 3B. Okay, so let's see how you got on with this one. So the natural numbers, what we mean by the natural numbers is 1 plus 2 plus 3 plus 4. Okay, so all the way up to 2n. So the first 2n natural numbers. So I want to find the sum of the first of all the numbers up to 2n. So a is 1, my common difference is 1, and my number of terms, the number of terms is equal to 2n. So the number of terms, I'm going to write down, here's my formula. Now the thing is, it's easy to get confused here because n is the number of terms. I'm just going to put that in a little circle. Okay, so this is my number of terms. I don't want it to get confused between, because we've got 2n for the number of terms. Right, so the sum, so instead of writing the number of terms here is 2n. 2 times 1 plus 2n minus 1 times d. Yeah, because what's here is 2n. The number of terms is 2n. A is equal to 1 and d is equal to 1, 2. So what I'm going to do now is multiply all this out and simplify. So my 2's will cancel. 2 plus 2n minus 1, just timesing it out by 1. So I've got n, 2 plus 1 is 1 plus 2n. And that was what I was asked to prove, that the sum to n terms is n times 2n plus 1. Right, I think that's enough work for today. And I'm just going to give you now what I've asked you to do on Show My Homework. So this is everything I'd like you to do, please, and the challenge here. Now, well done to everyone who is doing the challenge. Obviously, that will help you to do harder work and to get the higher grades. Okay, have a lovely day.